Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible, to the extent allowed by law, donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam P on probability. A random variable x has the log normal distribution with density f sub x of x equal to 1 over x times the square root of 2 pi times e to the minus 1/2 natural logarithm of x minus mu squared for x greater than 0 and 0 otherwise, where mu is a constant. You are given that probability that x is less than or equal to 2 is 0.4. Find the expected value of x. And note that you are supposed to know the log normal distribution for this exam. And here is the solution. X is log normal with parameters mu and sigma squared if its natural logarithm, so ln of x, let's write w for it, is normal with mean mu and variance sigma squared. From the form of the density function in this problem, we see that sigma is equal to 1. Therefore, the probability that x is less than or equal to 2, which is what we know to be 0.4, is the probability that ln of x is less than or equal to natural logarithm of 2, because natural logarithm is an increasing function. And that's equal to probability that ln of x minus mu over 1 is less than or equal to ln of 2 minus mu over 1, and we know this to be 0.4. Let us write z.6 for the 60th percentile of the standard normal distribution. Let z be a standard normal random variable. Then the probability that z is less than or equal to minus z.6 is 0.4, because of the symmetry of the standard normal distribution. Probability that z is less than or equal to z.6 is by definition of the quantile, 60th percentile, 0.6, but negative that, minus z.6 is on the other side of 0, and because the probability that z is greater than z.6 is 0.4, then the probability that z is less than or equal to minus z.6 is 0.4 as well. But the natural logarithm of x minus mu over 1, which is natural logarithm of x minus mu, is standard normal because of what we know about x. And therefore ln of 2 minus mu is equal to minus z.6, based on what we see there, that ln of x minus mu over 1 is less than or equal to ln of 2 minus mu over 1 with probability 0.4. So this means that mu is equal to ln of 2 plus z.6. And from the table of the normal distribution, the CDF of normal distribution, a standard normal distribution at 0.25 is 0.5987, and at 0.26 is 0.6026. And we want to find out what the point z.6 is, where that probability is exactly 0.6. Well, by linear interpolation, z.6 will be 0.25 plus a fraction of the distance between 0.26 and 0.25, or 0.25 and 0.26, and the fraction is established as the fraction of the distance between the two probabilities. So it's 0.6 minus 0.5987 divided by 0.6026 minus 0.5987. So 0.25 plus that fraction times 0.26 minus 0.25. Well, that's 0.25 plus 1/3 times 0.01, so it's approximately 0.2533. and this gives that mu is equal to natural logarithm of 2 plus 0.6, and that's approximately 0.9465. This, the mean of the log normal distribution, we should know that you should know that it's e to the mu plus 1/2 sigma squared. So in this case, since we established mu to be 0.9465, e of x is going to be e to the 0.9465 plus 1/2 of sigma squared, but sigma is 1, so it's 1/2 of 1. And that's approximately 4.2481, and that's answer A. We should remember this is copyrighted material. The problem and solution come from me. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited.